Chris, please take it away.
Thank you. All right, so today we're going to talk about labor and the future of labor as it relates to generative AI. And what does that actually mean? So my first question for everyone is, how many saw the last talk on this, which was the future of work? We got about half. That's great. That's great. So for those of you who haven't, I'm going to give you the very fast tour of that talk, just so you have context for this talk. All right. So predicting the future is a fool's game. People can't predict the future. When someone goes, "Oh, I know what's going to happen," you can't know what's going to happen. So, but what we can do is look at the past and then make a relatively good guess as to what is going to happen next, right? Cause and effect. So, so in the past, we have this timeline up here. It starts about 1950, it comes to right now. You're at this "you are here" kind of mark, and all the things that have happened since then. So it seems like, oh, that's a long time. But what we really want to do is talk about this blue line, which is the recent past. And the recent past is demarked on that line when we really heard about ChatGPT 3.5. That's November of about 18 months ago. So all the things that we talked about in that last talk were predicated on the fact that it happened in that short period of time, and then we were going to talk about what was going to happen in the next period of time. And that talk covered ChatGPT and large language models. So if you, that's actually on the Taggart Talk New Albany site, so if you want to catch that, you can go back and watch it. But we focused on the innovation of that during that 18-month period, and then we talked about what would be the guessable future, and the guessable future in that talk was really aimed at agent architectures and large action models. So agents being able to come in and do work for us. So a brief anatomy of an agent, which is code, so it's not something special, but it's code. But basically, an agent is a set of code. We give it a large language model. We give it the ability to execute code on its own. We give it some data, right? That's that bottom tier. We give it some capabilities to do planning and to be able to learn and adapt and change its behavior. And then we ask it to do things. We give it a role, we give it some goals, and we give it some tools that it can work with. And that's what an agent is. We allow singular agents or multiple agents to work together in groups to solve problems. So the concept there is no longer me talking to a chat interface, it's me asking a group of agents to go do work, they do the work, and they come back with that data, or whatever I'm asking them to. What's a large action model? Sort of the next step in the evolution of an agent architecture, where an agent is given then the ability to learn by demonstration, and it's given the ability to have structured logic, and then we give it the ability to have symbolic logic, the understanding of context, right? So now not only can we have something that could do work with tools and have skills and roles, but those things have the ability to think through and reason in context. And then we give it something to do, and it does it on our behalf. All right. You've now got the 40-minute talk in the last 5 minutes, so you don't really need to go watch that video now. All right. This talk, however, bridges the gap between digital work, which was all that, agents and large action models and sort of that, is all in the digital space. That's me working with a computer, or computers working on my behalf to produce documents and data and sort of work through that. But at some point, we step across that digital divide into the physical space. And that's what this talk is about, as we go from digital work into physical work. Thus work is knowledge work into labor, which is the manipulation of our physical space. All right. So what we're going to do here is cheat a little bit. As I said, the near-term future is sort of hard to guess, but I have to give us a little bit bigger runway. And the reason why I have to give us a little bit bigger runway in the guessable future is because physical devices like robotics have to be built, and then they have to get to us. So whereas digital things, we can drop code right away and it's available to us. Whereas if we're going to build something that then goes into a consumer market or a labor market and then actually gets in use and gets debugged and managed, it's a little bit longer runway. But we still have what has happened previously to sort of direct what's going to happen in that larger window. All right. So if you give me that one caveat that the near future is unknowable, I'm going to consider this now the near future. So we're going to talk 2 years, 3 years. All right. We're going to explore that transition from the digital world into the physical world by talking about 3 key elements that allow us to learn and allow us to actually do that transition. And that is being able to take a piece of hardware and train it, manage its form factor, and then talk about its usage. And so this talk is really about these 3 things and how we are taking, well, let's say robots. We're going to take robots and we're going to use these 3 techniques and these 3 things to sort of talk about what the future of robotics is as it comes to us and how we are going to interact with them on a daily basis. All right. So every time you see an ad for like Tesla or any of the other humanoid robots out there, they're doing what appear to be super mundane things. They're like, this is a whole thing about, they were very impressed that it can fold shirts. But if you think about that, folding a shirt is very chaotic. That's not an easy thing to do, and especially if you want to do it right. So I hate folding shirts, so I went and got one of those things that you put the shirt down, you flip it over, and then it makes the shirt, right? But if I could have a robot go fold a shirt, that'd be great. But even I realize that even when I use that simple device, I still have to line things up correctly. Shirts are different sizes, and sort of how that's all going to work changes. So there's this complexity, even in simple tasks. So when we talk about robotics and we talk about how does it interact with the world, we have to think at that level of chaos, that there is so much randomness that's happening here that I just can't write a bunch of code. We joke about self-driving cars. No, we don't joke about them. They don't like it. We talk about self-driving cars, and the concept there is you cannot if then else your way to a self-driving car. You cannot write enough code to make a car self-driving. Well, you're not going to be able to do the same thing here. You're not going to be able to write enough code to make this robot be able to fold that shirt, or any shirt, or a different shirt, or get a shirt from a different bin, or all things that happen when we talk about it. So when you see a robot doing something like this, what they're really trying to get across to you is they're addressing the complexity issue, rather than just a mechanical issue of how do I fold a shirt. So how do they do that? There's a couple different ways. We're going to cover, I think, 5 of them. But the first one that we're going to talk about, and these are in sort of order of usage. So we had this concept of large language models and action models and those kind of things. Now what we're going to do is how do we take those and make them smarter? How do we take those and be able to deal with the chaos of the physical world around a robot? So Lilo, which is a common sense knowledge predictor, right? So we have a couple sentences down here. You guys will understand this. Large language models do not, which is, while in a cave, he almost hit a bat with a bat. You know what bats this sentence is talking about. It's very difficult for language to understand it contextually. Now, I gave you context, cave. That's probably a physical animal, right? The second sentence, the batter tossed a bat and knocked down all the other bats, right? We know we're not talking about a Halloween creature that's flying around. We know we're probably talking about baseball or some softball or some other sport that requires a bat and has a batter. We get all this context immediately, and it's beyond just language. And we talked about that a little bit in the last talk, where language itself isn't enough for us to have great understanding. We also have to have context. And what Lilo does is it allows us to have that sort of context as something that wraps around these large language models. All right. So it's abstraction and common sense is what this training method gives us. All right. The next one, beep, ADA, which is action domain. And what this particular model allows us to do is create abstractions and context. So if I said, please bring the eggs to the table, it would depend on the situation as to how you would react to that. If you were making breakfast and you had just got done scrambling eggs, you would bring scrambled eggs to the table. If, however, we just returned from the grocery store and you had a carton of eggs, you would bring the carton of eggs to the table. It's contextual. Language models don't understand that. Robotics would have a hard time with that. We couldn't program that. So we had to come up with training algorithms that allowed us to think through how to teach something to have those kinds of abstractions, and based on the context of the situation it's in. So now we've given the ability to a robot to sort of understand the complexities of the language, and if we asked it questions in a weird way, it could go, okay, I know what it's talking about. And now we've added another training method that allows it to understand, oh, based on what's going on around me, I should do something different than probably what I had planned to do, or would have been programmed to do. We have language-guided abstractions, which allows us to deal or train a device to deal with unstructured environments. So a sentence that represents that is, bring me my hat. So we can go, well, there's some vision system, it recognizes hats, it knows, a hat from, an umbrella, those kind of things, but it understands my hat and from a whole rack of hats, so there's context there. Plus, if I was in a restaurant and asked my robot to go get me my hat, it may have to navigate to a code check. It may have to understand that my hat's not sitting directly where it is. If I'm at home and I ask this question, it may go over to my closet and open up the closet and get me my hat instead of my wife's hat and bring me my hat. If I'm at a golf course, it may realize I don't have a hat, or it's already on my head and I'm being stupid. All right. So this particular set of training allows us to think through and solve that problem. So now we can, with the first set of models in training, we can give it sort of the understanding of what we're asking. The second one, we give it the understanding of abstractions and context. And then this one, we allow it to learn a new thing, which is how to deal with unstructured environments. All right. The fourth one is large behavioral models. And a large behavioral model is the ability to give a robot haptic feedback. So if I had a robot and I wanted it to pick up this water bottle, I could come in, grab its hand, and pick up the water bottle, or show it me picking up the water bottle. And then that action model goes, oh, okay, I understand what happened. I have some kind of manipulator, I picked it up, I have possession of it. I'll stay away from that, because I think that's...
I don't know if that's it or not, but are you guys hearing a little feedback too?
Yeah.
Sorry.
I'll stand over here. Oh, it didn't change. Okay.
Do you still hear him? Okay. It's better.
I could just talk really loud, Neil. That's,
No, be
okay.
careful.
All right.
Sorry.
Yeah. So this is the ability to have a robot either physically be shown how to do something manually, or watch enough videos that it gets the gist of it, right? So now with these 4 training methods, we can put a robot in an unpredictable environment. We could show them the goal that we wanted to do and sort of how to do it. We can understand that it will know what we're talking about and it can situationally be aware. So these are the next steps in the progression. Before robots are with us every day, we have to learn these things, and the robots have to be able to do this. The last one is simulations. So the simulations are the ability to do thousands and thousands and thousands of repetitions of something in a simulated environment that then trains the robot to understand what its goal was and what it was supposed to be doing. So this is Albert. And Albert, it gets rewarded for doing good things like stepping on the little green box. Albert gets punished if he stepped on the box and then doesn't go to the door. And then Albert eventually, over thousands of training sessions, figures out to step on the box and go to the door and go to the next level. There's no programming. No one's doing that, right? If you want to go have a good time for about an hour and just laugh, there's this on YouTube called AI Warehouse, and you can actually see Robert or Albert learning how to do all kinds of other tasks. Now, this same simulation is also used on another site called 2-Minute Papers. The 2-Minute Papers site will do things like adversarial training. They will take Albert and they will take another robot, and then they have to play tag. And Albert has to not get it. And like, how does Albert learn to get away from somebody, and how does somebody learn to go get Albert? Those kinds of things are out there, right? But what's interesting is all of the data that gets generated here teaches robots how to achieve goals, where doors are, how to manipulate something in order to get to the next thing. So beyond just, hey, I need you to go out to my car and get my keys, if you think about that request, it's got to figure out elevators, it's got to figure out doors, it's got to figure out how to get outside, it has to figure out where my car is, it has to unlock the car, it has to get what I want, it has to get back inside, and it has to do all of those things, and this is how we train them. So I'll stop here a little bit if we want. I know we have a little time. Oh, Neil just gave me that look. I'm not going to stop here. I'm just going to keep going. All right. So let's move on. So this is training, right? So we just talked about like how do we train these things? Like what is this that, and how would they possibly learn how to do that? Well, these are how we've solved that problem. And there's many more, but those are the current sort of best. So let's talk about form factor. We all know this form factor, which is the giant robots working in factories form factor. We can see this form factor on occasion, which is smaller robots doing almost the exact same thing, but sort of in medical situations. And then these form factors are already deployed and in use. Right? So in the medical industry, this particular robot can help with suturing. It knows how to do that. I am going to do a shout out to a local company to us. This company's out of Dublin. They actually share an office space with us. And what these guys do is they ran into the issue of sonographers, people who run, what's a sonographer run?
Legal.
What?
Legal.
No, that's the stenographer. A sonographer runs
Sonogram?
sonogram, thank you. All right. So apparently the reason why you have to go get CAT scans a lot and MRIs a lot, even though something like a sonographer can actually do the work, is because there's a lack of them. There's not enough of them. So you have to go use more expensive medical equipment and something that's more invasive and radiology and those kinds of things, where we don't have to do that. We just don't have the people to do that. So what this company is doing is it's building a robot that understands the goal of a heart scan. And it can manipulate itself and touch you in order to get the exact correct heart scan based on its AI understanding, and then have a sonographer be able to read that and go, yes, that's good enough, and then that can be passed to a cardiologist. So this allows a single sonographer to read data in from multiple robots that are in the field, interacting with humans in patient or in beds, and then be able to pass that on, and it will then reduce the amount of time and effort it takes to actually get procedures without having to use CAT scans and MRIs. So we're working with this particular organization. I did want to do a shout out to them because you guys are awesome. All right. All right. So, but why do we see so many humanoid-shaped robots? Like every time we see, if you just went to YouTube and said robot, you're going to start seeing humanoid-shaped robots. And why is that? Well, besides they're fun to pose with, I said they're fun to pose with. Thank you. Cut out the non-laughing one. And then, all right. But no, let's go back. And how many people remember Vince and Larry? Show of hands. We know who the old people are. All right. All right, so Vince and Larry, and they were just sort of representation of crash test dummies. Crash test dummies are shaped like humans because that's good data, right? We want a crash test dummy shaped like us when we run a car into a wall, because that should give us an analog as to what would happen to us if we ran a car into a wall. Makes sense, right? Well, let's take it another step further. If you notice something about all of these robots, and these are current production robots, these are what is out there right now, you'll see that the average weight between these, and we'll skip this first one, but the average weight is between about 108 and 180 pounds. Seems to be human weighted. So it's not like these things weigh thousands of pounds. And it's not like they're 40 pounds. These are about human sized. If we look at the height, right? They're running essentially, the production robots are between 5'8", 5'11". So they're human-sized. Why would we start producing a lot of robots that are human-shaped, human-sized, human-weighted when we start programming these things to interact with us? Well, the obvious answer is because most things in the human world are manipulated by humans. So why would we build something that is not able to manipulate things in the human world? We wouldn't, right? That's sort of rhetorical. So Yamaha did a test. What they did is, instead of building a self-driving motorcycle, they built a robot that could drive a motorcycle. Let's think about that for a second. Instead of building a self-driving motorcycle, they build a robot that can drive a motorcycle. Instead of building a self-driving car, what if we built a robot that could drive the car? That might make more sense, instead of having to go down those branding things. If I can have a multi-use device, like a robot, interact with our things on a daily basis, that would create a lot less friction in conversion to allowing robotics into the normal day-to-day space. Right? If a robot could get into my car and drive it to, we'll go Chipotle, and pick up an order and then drive it back, and it's my robot driving my car, that's convenient. Like if I send it to Kroger and go get some stuff, right? It could use all my current things. I don't have to go buy a bunch of new things in order to make that work. So why make a humanoid robot? Because that's going to be a lot more convenient from a financial perspective and from a conversion and adoption perspective than it is if we made them some other form factor. All right, so let's talk about that usage. So we talked a little bit about why we do these samples of a robot folding laundry, but let's get into that a little bit. So currently, so we're not talking about the future, we're talking about currently, we have a set of robots in the Spanx factory, shelving and warehousing actual product, and that was released 6 months ago or so. They started actually in full force. About 3 months ago they did it. BMW, who I used to work for, already has robots in their plant in South Carolina and that they're working with. Tesla is releasing their Optimus robots actually into their factory, and they've already got 2 that are working full time. And they don't have to change anything about the factory. They don't have to go rearrange the entire factory floor to allow these robots to participate in the factory process, because they're acting as humans. So anything a human can do or get involved with, we don't have to custom build something to go do that, and I don't have to have 15 different versions of that custom robot if I can have a single humanoid robot that can work with humans. Right? Mercedes is also there. So it's not a surprise that the first entry into robotic adoption is in the factory space, because factories have already adopted robotics, and this actually makes it easier for them to expand their robotic workforce. Okay, awesome. I don't work in a factory. I'm not involved. All right. Service industries. Oh, okay. I was actually shocked that I live in Marysville. And there's a Mexican restaurant in Marysville that I go to on occasion, and a little robot swung around the corner and brought me food. And I was like, what in the heck is this? Like, I'm in Marysville, Ohio, and I got a robot delivering me food. It's like, okay, I can roll with it. But if we start looking at in the service industry space, labor, right? Service industry, the jobs we had when we were children. Not you guys, because you guys have cooler jobs than I had. I worked at McDonald's. Doesn't sound like those guys are going to be working at McDonald's. But someone's going to have to work at McDonald's. And if the next generation is starting their own businesses, they're not going to be working at McDonald's. So something is going to have to take that space. So I don't know if you've seen this particular demonstration. There was a lot to it, which was, this gentleman asked the robot for something to eat. The robot looked at its environment, picked up the apple, handed it to the apple. The reason why I captured this particular frame is because that apple was in flight. What does that mean?
You trusted it.
Yeah, the robot also understood physics. It understood that if it opened its hand, the apple was going to fall into the human's hand. So if you start looking at the subtleties of the demonstrations that you're seeing, you'll see a lot more complexity versus, oh yeah, they got a robot, picked it up and handed him an apple. That's not actually what this was showing. This was showing that this robot understood the simulation of our world and understood gravity. So it has been trained that if I drop something, it will fall. And it chose at that point to not wait until the person took it out of its hand, but to open his hand and allow it to drop. Interesting. But robots going across the sort of spectrum. Sanctuary actually has robots now that are stocking shelves in grocery stores and in convenience stores, and can sort of go back and rearrange the shelves and make sure everything is aligned properly. So these are things in our industry that are happening right now that we don't even have to like predict the future to do. Well, what we have to do is sort of realize that there's going to be more of it. And then what should our children do? Well, apparently start businesses. Seems like a great idea. And then in our personal spaces. So factories, obvious. Right? Service industries, yeah, people aren't going to work at McDonald's. But what about our personal space? If you think about labor and you think about the fact that a robot can fry an egg, or a robot can fold clothes, or a robot can make a bed, or a robot can sweep or vacuum, depending on what part of the country you're in, a floor, is it really a jump to go, well, hotels are just going to put robots in as maid service? Why would they not? Right, so that's a whole part of our labor workforce that is going to be, I don't know, it's replaced, but replaced. But robots now are making their way into sort of all of our personal spaces, from our homes, teaching. There's robotics showing up in classrooms, certainly in hospital space, and I think my prediction is over that 2-year period of time, we're going to see more of that. So what's tangible? Like, what does that tangible next future look like? Well, about 3 weeks ago, I think, Tesla announced that Optimus will be on sale in 2026. They said 2025. They pushed the date back to 2026, which means you can go buy one of these. And they're not hundreds of thousands of dollars. They're targeting $15,000. So if you could buy a robot and actually lease, because that's what they're talking about here, because you'll want the latest version all the time as they do updates. But if you can lease a robot that was humanoid shaped, that had the ability to take all of those learning mechanisms that we talked about earlier, and then can do things for you, like maybe not drive your car, I'm not sure we'd let that happen yet, but certainly do all the work around the house, fold the clothes, run the laundry, all those kind of things. 15 grand, I might be there. It seems like a good price point for me. But they announced last Friday, which I love these talks, because I just scan like what's going on right before these talks, so I could just pick these up. But last Friday, Tesla, or the group announced that they are combining Neuralink and the Optimus robots. So now someone who has a Neuralink implant can use an Optimus robot to do activities and control that task. So not just language, but also be able to manipulate the robot itself. all right? So, as we start watching more and more science fiction, we're like, no, that'll never happen, and then it starts to happen. It's like, all right, so now we can have essentially that sort of brain to robot interface. I mean, I have to use language. We can have sort of more complex things. But if you think about how we talked about those 5 training mechanisms, every conversation that you have with that robot is training not that robot, but every robot. Right? There's a great scene. How many people have seen The Matrix? I'm disappointed. Thank you. All right. Yeah, even if you haven't seen The Matrix, you could say yes on The Matrix. Right? All right. So there's a particular scene in The Matrix, and I won't ruin the whole movie for you, but essentially one of the main characters finds herself in a helicopter and says, I need to know how to fly this helicopter right now. And the guy on the other end goes, bzzz, and she goes, okay, and she starts flying the helicopter. That's what robotics is doing. If one robot learns it, all the robots can know how to do it. So as we do training and we teach something how to fold a t-shirt, it's not teaching this instance of this robot how to do it. It is teaching every instance of every robot how to do it. So now if we plug in Neuralink and it's able to then start understanding my thoughts, those robots who can understand my thoughts means every robot can understand my thoughts. All right? The next thing they announced is Tesla is making parts of the Optimus able to be used as prosthetics. So, it will be smart enough. It doesn't need, we talk about robots. It's like there's no processing in the head, right? It's not like us, where, but this leg has the ability to be a leg. And instead of a prosthetic that is dumb or just mechanically generated, we can actually have smart prosthetics. So if someone needs a leg or an arm, they can use those things. And now we're journeying into that whole cyborg kind of space. But this was just announced this week. That's their intent. So connectivity with Neuralink, and then the ability to use the robotic parts as prosthetics versus just an entire robot. But meanwhile, that leg knows how to work because it's been trained to walk around factories, it's been trained to walk up and down stairs, it's been trained to walk around our house, it's been trained to be connected to something else. We're just borrowing that training to help and assist on our sort of daily life. All right. So, unleash the power, or AI is the future of labor. All right, that's the sort of talk. And as you guys walked with me through the last one, I will finish out with this, which is this going to be sort of a dreamy utopia where we can all go to the beach, like robots are doing my work for me, I don't have to show up every day, it's able to clean the house, I don't have to do that work, it can mow the lawn, it can weed the garden, like all those things that I hate doing, it's able to go do for me. Or are we talking about a dystopian hellscape that we like are running from the robots Terminator style, right? Now, if you remember the last one, I asked OpenAI to give me a picture of a utopian or a nice space with a dystopian future, and it gave me a picture of sort of a rundown building, but we all had dogs. And it was like, seemed reasonable to me. So I asked this one to do for the same thing. I said, what would sort of our utopian society, happy humans look like if we were in a dystopian robotic hellscape? And it came up with this picture. And I want you to look at that. No dogs, apparently, but many, many types of robots. But what I really want you to focus on is these faces. We are so happy about our robotic overlords managing this for us. All right. So this is the second in this series. There's one more in the series about software development programming. However, I do want to do a plug for Columbus AI. So it's a meetup group that meets once a month. There's the meetup.com/Columbus-AI. And we meet and we have presenters who have conversations like this specifically about AI, all walks of sort of concepts and depth, and some are very technical, some are very high level, some are business oriented, some are marketing oriented, those kind of things. So if you have nothing else to do on a Tuesday night, and it's not random, it's the second Tuesday of every month, this group meets. We now have speakers throughout the rest of 24 into 25 now, so it's a thing. There's food there, and you can have a good time, and we'll have good conversations about specific AI kind of things. My name is Slee. I'm from Transform Labs. If you have any questions or you want to have conversations, here's an email address, or you can just come to the Columbus AI meetup group, and we can have fun there.